Okay, we're going to be looking at part two of the lab, where we're looking at metals, nonmetals, and metalloids. We're going to look at how we know for sure whether we're dealing with a metal or a nonmetal or metalloid, and other parts of how we classify things on the periodic table. So, much like how the metalloids are sort of a mix right in between metals and nonmetals, and they kind of are that fine divide between them. On the periodic table, they actually separate where the metals and the nonmetals are found. So the metalloids are in this kind of diagonal stair step that goes down and right on the right side of the periodic table. That includes boron, silicon, germanium, arsenic, antimony, and tellurium. These are the six metalloids that we're going to recognize in this class. And again, depending on what periodic table you look at, sometimes there's another metalloid that they kind of consider. But in this class, this is all we're going to consider. It's just these six right here: boron, silicon, germanium, arsenic, antimony, and tellurium. Everything to the right of their stair step is going to be a nonmetal, and everything to the left is going to be a metal. So aluminum, gallium, indium, tin, lead, bismuth, polonium, and livermorium are all going to be considered metals. And then everything over on the left side of that, except for hydrogen, we're going to count as a metal. Now, there is some debate in the scientific community about whether hydrogen is actually a metal or a nonmetal, because we have yet to really solidify it and be able to test its properties. But for now, in this class, we're going to treat it as a nonmetal. It mostly acts like a nonmetal for the ways that we use it, so we're going to treat it like a nonmetal. So lithium, sodium, potassium, beryllium, magnesium, calcium, everything in columns 1 and 2 except for hydrogen is going to be a metal. Everything in this middle section of the periodic table we've been calling the D block is also referred to as the transition metals. Those are all going to be metals. These guys down here, sometimes called the lanthanides and the actinides, part of the F block. These guys are all also transition metals. Okay. And then our nonmetals are over on the right side here. So carbon, nitrogen, phosphorus, sulfur, selenium, bromine, iodine, and everything down from there. And everything to the right of that are going to be nonmetals. So along the top, helium is a nonmetal, and along the right side with all your neon and argon and krypton, those are going to be nonmetals as well. Okay. Now, if we want to talk about where something is on the periodic table, we can tell by its column and by its row. We have some special names for that. So a column is also called a group going up and down, or it's also called a family. Since those elements have the same number of valence electrons, they tend to react and bond similarly. So it's kind of like they're all part of the same family. Okay. The most often used word we have in this class is group. So we could call this with hydrogen and lithium and sodium, potassium. All these guys are called a group 1. And all these guys, beryllium, magnesium, calcium, strontium, all of these with 2 valence electrons are in group 2. Everything with 3 valence electrons is group 13, and stuff with 4 valence electrons is group 14, group 15, group 16, group 17, group 18. You can also have groups in this middle section. Again, we call that the transition metals. So you could say like this with chromium, molybdenum, and tungsten, and I think it's seaborgium. Yeah. All these guys are going to be elements in group 6 of the transition metals, or you could talk about group 9 of the transition metals. We also have specific names for the rows. So going left to right, we call those periods. Okay, so a period is also a row on the periodic table. This is why we call it the periodic table. We have properties that are periodic that repeat once you start a new row. So once you get done with one row and go to the other, you have the same properties repeating from the row above in those columns. So we have the first row, also called the first period or period 1. We have the second row, and these go all the way across. So lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon are all part of the second row or the second period or period 2. We have stuff in the third period or period 3, fourth period or period 4, fifth period or period 5, sixth period or period 6, and then seventh period or period 7. Okay, the lanthanides and actinides down here in the D block are also part of period 6 and period 7. When we did electron configurations, the numbering for the D block and the F block got a little weird for the energy levels. We don't worry about that for period numbers. We're just talking about the actual row on the periodic table. So everything in this row, whether it's dropping down to a 5D or a 4F or whatever, all this is going to be in the sixth row, so the sixth period or period 6 of the periodic table. Okay. Now from there, you can also get some more specific names for some of these columns. Everything in group or column 1 is called the alkali metals group. Okay, so these are all alkali metals. Francium, cesium, rubidium, potassium, sodium, and lithium are all alkali metals. Hydrogen is also in the alkali metals group, even though we're considering it a nonmetal. So it feels kind of weird, but it's all in the alkali metals group. Beryllium, magnesium, calcium, all these guys in group 2 are part of the alkaline earth metals group. So if you've ever heard of like alkaline batteries, same kind of word there. These are frustratingly similar in name, but they are two different things. So column 1 or group 1 is the alkaline metals, and group 2 is going to be the alkaline earth metals. Okay. We don't have specific names for all the stuff in the middle. We just call it all the transition metals section. Okay. Over on the right side, we have been calling this column 18 or group 18 the noble gases for a while. That's our name for this group, this column. So helium and neon, argon, krypton, xenon, all these guys are noble gases. They're in the noble gases group. Fluorine, chlorine, bromine, iodine, all these guys with 7 valence electrons in group 17 are known as the halogens, kind of looks like halogens. That word derives from a word that means salt forming. So we tend to have salt-like compounds formed out of these elements, and usually a metal that comes with them. Okay. There are interesting names for some of these other groups too. Like group 16 is sometimes called the chalcogens, if I remember correctly, and group 15 is sometimes called the pnictogens with like a silent P on the front, so it's like pnictogens. But those don't get used very often anymore. Instead, we go with the easier route of calling them by their top element. So everything in group 16, like tellurium and selenium and sulfur and oxygen, are all part of the oxygen group. Okay, and everything in group 15, hydrogen, phosphorus, arsenic, are part of the nitrogen group. Group 14 is the carbon group, and boron is the top of the boron group. Okay, and group 13 is the boron group. Okay, so we can specify where something is placed and what its properties are based on kind of where we put it and what we call it. So in this assignment, we're going to be looking at how we categorize things, or I guess technically it's the other part of the lab, but it's not very lab-like. We're going to be categorizing elements and finding them based on how they're placed. So let me scroll this down here. Okay, so for example, a gaseous nonmetal in group 16 and the second period. Okay, well, group 16 is the same as saying column 16, which would be like these guys here. Oxygen, sulfur, selenium, tellurium, polonium, and livermorium. Okay, and we're also looking for something that's in the second period. The second period is the second row, so it also needs to be in this part here. So we're going to kind of play battleship with this, where we want something that's in the second row and also the 16th column. That is going to be oxygen. So I'm going to go find oxygen down here and match it up. See, there it is. And drag this all the way to the top and drop that in there. Okay, let's look at another one. This one says a solid metal in group 11 of the transition metals in the fifth period. Okay, so the transition metals is that center section, the D block. Group 11 is going to be the 11th column that is in the transition metals. And then we're looking at the fifth period, the fifth row. So overall, the 11th column is this guy right here with copper and silver and gold. And I think it's Röntgenium or Röntgenium. I'm not sure exactly how to pronounce it. I should probably look that up. Okay, but this is group 11 right here. So it's going to be one of these 4 elements. And then I believe it said, oops, period 5. Yep, fifth period. So our fifth row is this right here. So we're talking about silver in group 11, also in group 5, or sorry, period 5. So we need to match up silver with that. So grab silver, take it on up here, and drop that there. Okay. Some of these are going to be easier than others. Like they'll give you more information to work with or less information. So let's see. This one's saying a solid metalloid in the third period. Well, this doesn't tell us what column we're dealing with, but let's look at what's in the third period. Okay, so in row 3, we have sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, and argon. Well, in the third row, we only have one metalloid, and that's silicon, and it also happens to be a solid. So we must be talking about silicon here. So let's match up silicon with that. Silicon is a solid metalloid in the third period. Okay, we have another similar question like that, a solid metalloid in the nitrogen group. So again, it doesn't tell us the period in this case, but maybe there's only one metalloid in the nitrogen group. So you might be able to match it up like that. Okay. So good luck with matching those up. And these should all be elements that you saw in part 1 of the lab.